All right, class, welcome to week 6 of distance learning for science, 8th grade. Mr. Kunishima's class. A little bit different this week. I've got a lecture that I'm going to kind of do on PowerPoint. More than welcome to take notes. More than anything, I just want to make sure that for this week, I wanted to try and do something different. And the difference that I wanted to do was to let you guys have a little bit of fun. So I want you guys actually to do a lab, and I'm going to give you all the information on how to do the lab within this PowerPoint. So we're going to work on sound and light properties. It's week 6 of distance learning. So for this week, we're going to do Monday light and sound waves. We're going to do a little terms lecture. We have a little videos assignment for Mondays as well. For this one, what you're going to do is you're going to watch 3 videos of your choice that you can Google. They can be anywhere from a minute to 4 or 5 minutes or longer. And you just have to watch the video, then post onto your GoFormative in the questions at least 3 sentences on what you learned, but also make sure that you post the URL so I can take a look at that as well. And then finally, at the end of this lecture, I'm going to share with you the project for this week. So what I'm kind of hoping is that on Monday, you do this lecture listen, you do your videos, and then Tuesday, Wednesday, Thursday, and Friday, you're going to be doing your project. And it's a Flipgrid video, and I'll explain it at the last slide. But more than anything, hopefully you'll have a little bit of fun with it. So let's start off today with talking about light and sound wave terms. So one of the terms that you have to know is something called reflection. Reflection is when a sound or light wave bounces off another object. So for example, this picture of a flashlight hitting a mirror and then reflecting off. Some other things that you don't need to know for 8th grade, but might be able to know for later on in physics class is angle of incidence and angle of reflection. Angle of incidence is the angle that you're starting with. Angle of reflection is after it's reflecting. So what you can see is that it's an equal angle as it goes in. So if it's, let's say, steep like this, it'll come out steep. Sound waves do the same thing, but they're also going onto a surface. And if it's reflection, that sound wave is moving toward this wall and then bouncing back. Sometimes when you hear, let's say, an echo, you're hearing the reflection of the sound waves that are bouncing off, let's say, either rocks or something else. Moving on to the next term. So next term is called absorption. Absorption is when a wave comes into contact with a medium and causes the medium's molecules to vibrate and move. So on the left side, sound booths are going to use foam triangles to absorb the sound. You'll see this anytime that you're going into, let's say, a recording studio or some type of sound booth. And what you really want is just the best acoustics for the microphones that are just picking up what that sound is going to be, whether it's singing or an instrument or whatever it happens to be. And what happens is that the sound waves actually get absorbed by the foam triangles to make it so that you have the most clear, pure sound that you could have. For a light wave, in the past, what I've done with this one, when you're talking about absorption, is I use a prism. What happens is the light wave, let's say it's a white light, like a flashlight, goes into a prism. That's this acrylic or glass prism. And when it's directed right at it, it will absorb the light. And as it absorbs the white light, it pretty much brings out all of the electromagnetic spectrum, which gives you all of the colors of the rainbow, Roy G. Biv, which is red, orange, yellow, green, blue, indigo, and violet. So that's absorption. Sorry about my misspelling up here. This misspelling right there, it should be a B. The next word is called transmission. And acoustic transmission is a transmission of sounds through the materials, through and between materials, including air, wall, and musical instruments. When it comes to light transmission, it's the moving of electromagnetic waves, whether visible light, radio waves, ultraviolet, etc., through a material. So this transmission can be reduced or stopped when light is reflected off the surface or absorbed by the molecules in the material. So on the left picture, you can see that a sound wave is going to get absorbed by, let's say, a wall. You might be able to hear something, some of what that sound, but you may not be able to decipher exactly what it is because the absorption is kind of muting a lot of it. For light waves, you have the picture of the light coming in. You've got the red, the green, and the blue. It hits onto a surface that absorbs. That means that the light is actually going in. For example, if you have, let's say, a black top, a lot of the light that hits the black top is going to be absorbed, and that's going to be absorbed and get really hot because that surface is absorbing. If you have, let's say, a white shirt versus a black shirt, and you go out in the sun, the black shirt is going to absorb all of that light and that heat, and that's going to make it much hotter. A white shirt's going to make you much cooler. So here's a little video, and I want to show it so you guys actually have a chance to watch it. There, again, are plenty of other videos to watch, but I did want you guys to watch this one.
Transmission of sound. Every sound is produced by a vibration. Vibration is the back and forth movement of an object. As you speak, vibrations are produced by the vocal cords in the throat. You can hear only when the sound energy reaches your ears. But how does sound energy travel? Wonder how that works? Come, let's go across to Dr. Zook. Sound energy travels in the form of sound waves. There are mainly two types of waves, transverse wave and longitudinal wave. Let us see how waves travel. We can use a slinky spring to observe both types of waves. Emily is holding one side of the slinky, while Dr. Zook is holding the other end. With a quick upward flick of the wrist, Dr. Zook has sent energy traveling through the slinky. Notice how the slinky moves? This is a transverse wave. In a transverse wave, the particles vibrate at a right angle to the direction of the wave. The wave traveled from Dr. Zook to Emily and back. Now let's see what a longitudinal wave looks like. Emily is holding one end of the slinky, while Dr. Zook is pulling its other end towards himself and then pushing it towards Emily. Watch closely, and you will notice that some of the coils crowd close together and then slowly move farther apart. This is because the vibrations are parallel to the direction of the wave. If the wave moves from right to left, then the particles also vibrate from right to left. This is a longitudinal wave. Sound waves are longitudinal waves. These waves travel at different speeds in different mediums. The medium could be a solid, liquid, or gas. Now let's see how this works. In a solid, the particles are very close together. Sound energy moves as one particle hits the other particle. With the particles being so close together, sound travels quickest through a solid. If we look at particles in a liquid, they appear to be slightly further apart when compared to solid. Thus, sound energy takes a little longer to travel through a liquid. Look at the particles of gas. They are spread out, and hence, sound waves travel most slowly through them. Now we know how sound travels in different media. The vibration of particles produces waves. Wavelength is the distance between two consecutive compressions or rarefactions. The number of waves passing through a point in a second is called frequency, and it is measured in hertz. Sound waves travel in all directions. Sound gets reflected. That is, it bounces back on hitting a solid surface. Bouncing back of sound is called echo. Bouncing back of sound is purposefully used in detecting depth of seabeds. That's amazing, isn't it? Summary. Every sound is produced by a vibration. Vibrations are produced by our vocal cords when we speak. There are two types of waves, transverse wave and longitudinal wave. In a transverse wave, the particles vibrate at a right angle to the direction of the wave. In a longitudinal wave, vibrations are parallel to the direction of the wave. Sound waves are longitudinal waves. Sound travels quickest through a solid. Wavelength is the distance between two consecutive compressions or rarefactions. The number of waves passing through a point in a second is called frequency, and it is measured in hertz. Bouncing back of sound is called echo.
Okay. All right, let's go to the last one. So the last one is called refraction. Refraction or diffraction involves a change in the direction of the waves as they pass through an opening or around a barrier in the path. Something that you can do for your project coming up is you can show that a pencil, when placed in a glass of water, and the glass is actually a clear glass, actually looks like it's broken. And so that's going to be refraction. And so what it does is it actually kind of changes the look of the wave, so it kind of moves it and makes it look like it's kind of an optical illusion. For sound waves, there's a video I have on refraction of sound waves as an example of what you can use on the Go Formative. But the picture right here is in cooler weather, the sound travels slower. In warmer, it travels faster. And so in the daytime, you'll see that the sound waves actually kind of go up, whereas at nighttime, the sound waves kind of go down. So that's kind of how refraction works. Oops, last slide, and just kind of a summary. So we have Light and Sound Wave Project, Tuesday through Friday. So in the Go Formative, you have to watch this video, and then you also have to watch at least 5 other videos, but you only have to write 3 sentences about 3 of them. So try and get more than 3, but watch 5, and then you just have to write 3 down in your Go Formative. Make sure you write 3 sentences for each, and just pretty much what did you learn. Also make sure that you're adding the URL so I can see kind of what videos that you guys actually did watch. And after you do that, let's see, next watch the video on Monday's Go Formative called Exploring Light, Absorb, Reflect, Transmit, or Refract. It's the last video on the Go Formative. After you watch that, it should give you an idea of kind of what I'm looking for as far as what you can do at home. So I wanted you guys to do a lab, and it was more of a home lab, like a lab that you can come up with, and it's materials that you can do. So I'm not asking you specifically for you to do specific materials, but you can do whatever materials you want. For example, you can use glass and water and a pencil. You can use laser pointers or laser pens. You can use flashlights. You can use tin foil, aluminum foil, saran wrap. You can use, what is that other type of foil that is parchment paper that's kind of opaque. You can barely see through it. You can use your own musical instruments if you guys are into playing music. And what you're going to end up doing is you got to come up with a lab that you can do at home that you can demonstrate sound or light waves. and at least one of the terms that you learned from today's PowerPoint. Video yourself doing the lab and explaining it, and then upload it into Flipgrid into your period. So what I did this one is I have 5 different codes, and make sure that you upload into your period. If you do it to the wrong period, you're not going to get credit. So make sure you go. If you're in period 1, go to period 1 code and upload your video there. All right. Now, some key points that I have up on the Go Formative. Make sure that you are showing your face, like I'm showing mine right now. If you do not show your face, I'm going to take 5 points off of your project right away. The video must be at least 30 seconds. If you don't hit the 30 seconds, you're going to lose 5 points. No more than 2 minutes. It's probably going to stop you at 2 minutes. Let's see here. Want to make sure that you get enough time to do this. So pretty much you have the whole week, Tuesday, Wednesday, Thursday, and Friday to work on it. And it's due on Sunday. It's worth 25 points, and this is going to be an assessment grade. So it's like a test, and it's out of 25 points, so it's going to be a big one. So it's kind of a make or break. It's either going to help you a lot or hurt you a lot. And there's not going to be any quiz because this is going to take in place of the quiz. Okay. All right, so that's all I have for the PowerPoint. Let me go ahead and shift off that. And let me just go ahead and find Go Formative. Just going to make sure that you understand what you're doing on the Go Formative. So 5/4 light and sound waves. I'm going to place the PowerPoint lecture right here when I'm done. This is an example of a video that you can watch. You can watch that one. Find a video to watch and answer the question below. You need to do one video, type at least 3 sentences with the URL, a second video, and a third video. It would be nice to watch a couple more, but you only have to do 3 and you'll get points for that one. Then you're going to watch this video down here. This is kind of a exploring light, absorbing, reflecting, transmitting, and refracting. Once you watch this, this kind of gives you an idea of what brainstorm me as far as like what I want you guys to do for your project. I want you to write down an idea for your project. I'll give you 10 points for that. And then down here, you'll post on Flipgrid your project video. For this week's Flipgrid, please make sure I can see your face. You will automatically lose 5 points if I cannot see your face. This week we'll also post by periods. Please post only in your period, as I will be grading straight from Flipgrid for this week's assessment grade. Overall points will be 25 points, so this is a lot. Do well on it. And then when you log into Flipgrid, use the codes to get into your period. So it's these codes that are right there. We'll probably also give you the overall general code to get into Flipgrid for my class. Okay? If you have any questions, email me. Let's see, I should be available either Tuesday or Thursday for individual Zoom meetings. So what I'm going to do this week is, if you feel like you need to do a Zoom meeting with me, you are a little bit confused, you need a little bit of help, I want you to email me and request, Mr. Kunishima, can I please have a meeting? I will then say yes. I will give you what the Zoom code is, and I will tell you what time you have to be on there for. Okay? So if I have more than, let's say, 100 people that need it, then I'll start at 10 and go until everybody's done. I haven't had a lot of people that have needed to do any one-on-one meetings with me, but I want to make that an option, at least for this week. So if you're confused about what to do, okay? So I should be able to do it both on Tuesday and Thursday. Keep on the emails and I'll let you know how that goes, okay? I think that's it. So as always, hope everybody's doing well. Everybody stay safe. And boy, after this week, there's only, I think, 3 more weeks of school. And that last week, I'm not going to do a whole heck of a lot with you. So I would say we've got this week, we've got a week and a half, and then we're kind of shutting down the grades of part of it. So have fun this week, and we'll see you.